For question 5, we are given two functions, f and g, and also given that ff is equals to g. We are asked to find the value of b. So to start off with this question, we should probably find out what the composite function ff will look like. So let's try that out. So ff, the composite function, so we have ffx. What we do is we sub in the first function fx into fx again. So let's sub in fx once first. Equals to fx is x plus a over x plus b. To sub it into f again, anytime we encounter x, we'll use x plus a over x plus b instead. So what we have is a very complicated fraction. We have x plus a over x plus b. This takes place of this number x here, plus a over, this x will be replaced with x plus a over x plus b plus b. So now a lot of algebra work to simplify these fractions. So we will multiply both the numerator and the denominator with x plus b to get rid of this fraction over here. So multiplying this fraction with x plus b gives us just x plus a. Multiplying a with x plus b gives us a bracket x plus b. Over, the denominator is multiplied by x plus b as well. This fraction becomes x plus a. And b will multiply by x plus b. So we'll expand and simplify. X plus a on the numerator plus ax plus b. On the denominator, we have x plus a plus bx plus b squared. Okay, we'll group all the terms for with x's and group all the constants. So what we have is, we take out x for these two terms. We have 1 plus a, x plus a plus b, over these two terms with x's, 1 plus b, x plus a plus b squared. Okay, so this complicated fraction is the composite function ffx. So we are also told that ffx is equals to gx. So now let's write down ffx is equals to gx. So this complicated fraction, 1 plus ax plus a plus b over 1 plus b x plus a plus b squared is equals to gx is given to us as the function x. We will cross multiply. So we have 1 plus ax plus a plus b equals to 1 plus b x squared plus a plus b squared x. So this looks really complicated. How do we tackle an equation with so many unknowns with a, b, and x? So the important idea behind this question is that this equation is true for all values of x inside our domain. So it's true for multiple values. For such cases, we can compare coefficients. So we can compare the coefficient of x squared. So this side doesn't have x squared, this side has x squared, so we can compare coefficients. We can also compare coefficients of x as well as the constant. But the simplest way to solve this question is simply to compare the coefficient of x squared, since we only are interested in the value of b and not a. So what we have, if we compare coefficients of x squared, we have 1 plus b is equals to 0, giving us b equals to minus 1. And that is our answer for the first part of the question. For the second part of this question, we are asked to find f inverse x in terms of x and a. So this question, we can do it the regular way, and we'll do that actually later, but there's a very quick way if we spot a trick to handle this question. So the trick goes this way. The question tells us that ff, the composite function, is equals to g. And gx happen to be a very special function. Gx is an identity function, gx equals to x. So ffx equals to g, so ffx equals to x. We are asked to find what f inverse is. So this is where we can apply a trick. Let's apply f inverse, the function, on both sides of this equation. So we have ffx equals to x. So if we apply f inverse on this side, we apply f inverse on the right side as well. This is what we will have. And then we have a very special identity. F inverse and f are opposites of each other. So f inverse and f will cancel each other out, leaving us with just fx on the left. So f inverse cancels with f, leaving us with fx. On the other side, we have f inverse x. And turns out we actually have found the answer for f inverse x by applying this trick. So what is f inverse x? F inverse x is just fx. Therefore, f inverse x is equals to fx is equals to, and then we copy the formulation given to us, which is x plus a over x plus b. In part 1 of the question, we have found that b is minus 1. So we have equals to x plus a over x minus 1. And this is our solution. So if we can spot this trick in our exam, we are able to do the second half of the question really fast. However, if we can't spot such tricks, we can also approach this sort of questions with the standard approach to find inverse functions. So let's try that out to see that we will indeed arrive back at this answer. So for the alternative approach, we have that fx is equals to x plus a over x minus 1, since b is minus 1. So what's the usual way to find inverse functions? We can let y be fx, which is x plus a over x minus 1, and proceed to make x the subject. So how do we do that? We cross multiply. We have xy minus y equals to x plus a. Let's group all the x's together. We have xy minus x equals to y plus a. Factorizing x gives us xy minus 1 equals to y plus a, and x equals to y plus a over y minus 1, sorry. So this is our formula for f inverse, changing all the y's back to x's. F inverse x is equals to x plus a over x minus a.